Hi friends, in this video I will explain concept of simple parity check code for 5 marks. So this concept it comes under the linear block codes. Linear block codes is a code in which the exclusive OR of two valid code words create another valid code word. Minimum distance for linear block codes. The minimum Hamming distance is the number of ones and non-zeros valid code words with the smallest number of ones. So here first we are going to discuss the simple parity check code. In this code, k bit data words is changed to an n bit code word where n is equal to k plus 1. The extra bit is called as the parity bit is selected to make the total number of ones in the code word even. If you observe this diagram, we can easily understand that, right? The purpose or maybe the finding of n. A simple parity check code is a single bit array detecting a code word in which n is equal to k plus 1 with a d minimum is equal to 2. So here it has been divided into the A0, A1, A2, A3, and then by means of generator we are going to generating a parity bit, so that you input and then the returned bit it has been added and then that it has been passed on to the unreliable transmission medium. So it will receive on the B0, B1, B2, B3, and then the Q0 it is the whatever the parity bit we have added, and then by means of checker it is going to generate, right? Whenever we get the S0 bit as a 0, then it is going to confirm that there is no errors it has been present. Apart from that, one it is present or any other number it is present, then it will discard. The encoder uses a generator that takes a copy of 4-bit data words A0, A1, A2 and A3 and generates the parity bit R0. The data word bit and parity bit create the 5-bit code word. The parity bit is added to the makes a number of ones in the code word even. A simple parity check code C of 5, 4. So this is what of corresponding data words and then code words. So it has been starting from 1, 2, 3, 4, 5, 6 like that. We are going to generate after the 15 bits or maybe 15 data words. So this is normally done by adding the 4 bits of data word modulo 2. The result is the parity bit. In other words, R0 is equal to A3 plus A2 plus A1 plus A0 modulo 2. If the number of ones is even, the result it is 0. If the number of 1 is add, the result it is 1. In the both cases, total number of 1 is the code word is even. The sender sends the code word which may be corrupted during transmission. The receiver receives a 5-bit word. The checker at the receiver does the same thing as the generator in the sender with one exception. The addition is done over all 5 bits. The result, which is called as a syndrome, is just a 1 bit. The syndrome is 0 whenever the number of ones in the received code word is even. Otherwise it is 1. S0 is equal to B3 plus B2 plus B1 plus B0 plus Q0 modulo 2. The syndrome is passed to the decision logic analyzer. If the syndrome is 0, there is no errors in the received code word. If the data portion of the received code word is accepted as a data word. If the syndrome is 1, the data portion of the received code word is discarded because the data word is not created.